What is going on, guys? I am Miguel from UCGym.com, bringing you another video, and today we're going to discuss physics in fitness. Now, if you watch many powerlifters videos or read any of their articles, a lot of them will say force equals mass times acceleration. Now, that is a physics equation, and what they're trying to say is that the bigger you are, the larger your mass, the greater force you can expend on weight. So if you don't know, powerlifters are athletes who try to pick up weight in the three main lifts, the bench press, squat, and deadlift, and they try to pick up as much weight as possible for one rep. Now, yeah, you see a lot of them, they get very big and they're able to pick up really heavy weight. If you look at the elite level of powerlifters, those who squat over 800 pounds, deadlift over 1,000, bench over 600 or 700, you'll see that they're pretty big guys. They consume tens of thousands of calories a day, and they have to do that in order to get big and pick up heavy weight. Now, we're going to talk about physics in bodybuilding and in any other physical sport. So I read a couple articles and did a couple little research on how it applies to fitness. Now, I took physics in 11th grade, so my physics is a little rusty, so I had to do a little brushing up. But anyways, so one person was saying that force equals mass times acceleration, or force can equal acceleration times mass. Now, what he's trying to say is that the force that you expend on the weight is relative to the mass of the weight and the acceleration that you exert on the weight, or it can be relative to the acceleration you expend and the mass of the weight. So in bodybuilding, let's say you're going to do a bench press, similar to in powerlifting. Now, the force that you expend is going to equal how much the weight of the barbell is and the weight on it and the acceleration you expend on it. So if you're expending, let's say, 135 pounds of force and the barbell weighs 135 pounds, it's going to be at a plateau. So if you're exerting 135 and the barbell weighs 135, you're going to be stuck. Now, the acceleration determines how quickly or how much the weight moves up or down. So if you accelerate and you drive yourself just a little bit, the weight will go up, therefore the force will go up. So this sort of helps you understand what it means when they say force equals mass times acceleration. The more you accelerate, the greater the force you exert. So the mass, as I said, the mass can be great and the acceleration can be low. So if you look at an elite powerlifter, you'll see his bench press, when it gets to a very high weight, the speed is pretty low, but the weight is pretty high. And the mass, or the force, is pretty much as what he's exerting. So the mass can be great and the acceleration can be low, but similarly, the acceleration can be great and the mass can be low, but the force will still be the same. So if you're exerting 135 pounds of force, the acceleration can be low, but the mass can be high, and the force will still equal 135 pounds. So you can interchange how much force, how much acceleration, and how much mass is involved, and you'll yield the same result. So in other words, the barbell goes up on the bench press slowly because the mass is high, or it goes up quickly because the mass is low. So if you're doing a warm-up with a 45-pound barbell and you're this one individual, so you're warming up with the 45-pound barbell, the mass of the barbell is low, so you're going to be moving it pretty quickly, therefore the acceleration is high, and you're getting this amount of force. Now if you start adding weight onto it, the acceleration gets slower, the mass is increasing, and the force is going to equal the same relative to the weight. So as I said earlier, the acceleration, the force that you're exerting on the weight has to be greater than how much it actually weighs in order for it to actually move. So, like I said, 135-pound barbell with weight on it, of course. You're exerting over that weight in order to make it move up. So if you're exerting less force than that, it's going to go down. Same way as if you're relaxing to go down on the negative of the bench press, the force is going to be lowered, therefore it's going to go down. So if you're saying I can bench press 450 pounds or something, you can actually do more than that, but it won't necessarily go up. You'll be at a platonic state, but nevertheless, you're able to handle more weight than you think. So an example being firing a bullet out of a gun. The acceleration is very high because the mass is very low. If you try to compete let's say a sniper rifle versus a shift cannon, the mass is greater and the acceleration is probably the same, but the ship's cannon can probably go further due to the force that's generated through the mass and acceleration put together. I mean, kind of makes sense. Yeah. So another thing I read is that the exertion of force can also be dependent on a reflex or elasticity involved with the necessary sport or thing of that matter. So you can relate this to baseball, where a pitcher is winding up his arm to throw the ball. You can see that he's stretching his arm back and he's elongating the muscle fibers of his shoulder and elongating the tendons. Now once you get to a certain point, you can't go any further. Your muscles and your tendons are pulling back on your shoulder to make it return to its normal state. So not only is the athlete using his own strength, but also using the body's natural reflexes and force to throw it back. So this is also related to a bench press, where you go down and the force or elasticity that's in your chest muscles, it'll drive the weight back up. So not everything is dependent on your sole strength, but it's also dependent on your body's physiology and anatomy and what makes it drive the weight back up or exert the force that it does. So next, explosive force, pretty much instantaneous force, and gradual force or slow exertion of power. So you don't necessarily need explosive force in the gym, but you more so need it in everyday or practical life. So if you were to put a world-class bodybuilder versus, let's say Muhammad Ali, you wanted to test how strong each of them are. Well, their strength is relative to their sport. So if you wanted to have a bodybuilder bench press 425 pounds, he'll do it easily. If you want to have Muhammad Ali do it, probably can't even pick the weight up. So their strength is different, but it's relative to what they need to do it for. So now if you try to do the test on Muhammad Ali's strength versus bodybuilders in terms of his punch, Muhammad Ali can have, let's say, a 1600 pound force punch, okay? Now the bodybuilder will have probably nowhere near that because his force is very low due to the acceleration that he exerts. So a lot of bodybuilders or athletes or people who weight train, you see that they maintain a low tempo or a slow pace when lifting weights. They do it because the mass of the weight is pretty high and they need to control the weight in order to prevent injury. So the bodybuilder can grind out 425 on the bench press pretty easily, but he's going to do it at a steady pace because he's not that strong to the point where he can just throw the weight around. But Muhammad Ali, he's able to exert all his force instantaneously because that's what the sport requires. So in physics, force equals mass times acceleration. So the mass of the weight goes up slowly because the acceleration, or I'm kind of mixing things up right now, I'm getting myself confused, but you should probably understand what I'm trying to say by now. But another example of this thing in physics is running. So the force that's exerted, let's say, on your joints when you're running, like your knees, your hips, and your ankles, is relative to your mass and the acceleration at which your limbs are hitting the ground. So if you're running at, let's say, a steady pace of 10 miles an hour, your force would be pretty great if you were to like run into someone or do something of that sort. But if your mass increases, let's say you weigh 200 pounds and you're running at those 10 miles an hour, the force you exert is going to be pretty great when you run into a person. Similarly, when you're running and your feet are crashing into the ground, providing instantaneous force, and your joints are absorbing all that force. So pretty much what I'm trying to say, physics is applied to fitness. It's pretty interesting to understand how this works. If you want to lift heavier weight in some sort of way, then increase your mass, but don't necessarily just eat McDonald's every day and expect to be able to bench press a whole bunch of weight. You also have to keep in mind you have to work on your acceleration of the weight as well as the mass of your muscles to keep up with the mass of the weight. So you have to be relative to everything that's going on. That's pretty much it. I just want to bring this up because I found it pretty interesting when I was watching a guy discuss, or just mostly bring up force equals mass times acceleration, where he was saying the bigger you are, the more force you can produce. But just wanted to kind of clarify this and bring this up. Yeah, that's pretty much it. But if you want to see more things like this, head on over to UCGym.com and subscribe to our YouTube channel.